So I'm going to go ahead and record this lesson for this very fun snow day we're having so that you can get your attendance and your notes written if you were not able to come to the online Google Meet session that we recorded or that we provided today. So make sure that as you go through these notes, you're writing down the notes and then you're going to submit them. I know you don't have the worksheets, so yes, you're going to have to write down a little bit more than we usually do in class. You can pause the video if I'm going too fast on any one section, just make sure that you get all of the notes written down. And then at the end, what I'll have you do is submit them to the Google Classroom. There's already a spot on there for LP7 days 1 through 4 instead of 1 through 9 here, but we're adding an extra section onto this one. So you just submit it on there, and I think it even says snow day notes. And that way I can give you attendance if you weren't able to attend the Google Meets. All right, so we'll go ahead and get started on here. So this is just our very first slide we always go through. So this is the class expectations. Make sure that you are logging into alex.com and working on your homework, topics, tests, and quizzes as they're assigned each week. Remember, 10 topics every week. That's worth 15% of your grade. Homework, that's a huge chunk that's very important to be working on. We're not going to work on any homework on this video or in class for the Google Meets because we're not really set up for that without all the worksheets. So really this is just about getting the notes to help you work on your homework. So make sure to go back in and work on all of your homework this week since we're not doing it in class. And we never finish all of the homework in class anyway. We only ever do a couple of problems together. Tests and quizzes, remember you'll have one or the other every Monday. Just depends on if we finish a chapter, that would be a test. If we're still in a chapter, that means we're going to have a quiz that following Monday. Attendance is required, which is why we're providing this. We don't have the time this semester to play catch up at all. There just isn't any extra weeks in the semester to do that. So we need to make sure that we're staying on track. So we can't be behind a week a little bit like we could in the fall semester. So make sure that you're keeping up on the attendance and you're coming to class each week or attending in this way if we need to. Work completion, all of it gets completed on alex.com with the exception of sometimes classwork. If we can do that, all work is due every Sunday. There are extensions available, so even after an assignment closes out, it's not clickable anymore. You can always ask me to reopen it so that you can go back and work on it and get a better grade. But you do need to ask me, that way I can go back and I know which assignments I'm supposed to be going back to look at to grade. So there's not quite so many open all the time. All right, resources, tons of resources. I say this in every class. You guys are a bit spoiled with resources. It's amazing. But a lot of our students aren't using them. So make sure you have in-center tutoring if you already have that set up with Miss Anna. We don't have a lot of other tutoring available right now because she's got limited times. So if you don't already have a space with her, you can use the FEV or FEV tutoring, however we say that. I'm not really sure what the correct pronunciation of it is, if we say it together or separately like that. This is through clever.com. You go down to the bottom of your clever.com account and you will see this FEV or FEV tutoring. It's 24 hours, 7 days a week, free tutoring to you, all students. Make sure you're using that resource. It is an amazing resource. I made YouTube videos for every single one of your homework assignments. So if you get stuck and you need a live demonstration or, I don't know if we'd call that live, but you need an actual visual representation of your homework or example, go on there and watch me do it on the videos. You can also ask me questions directly from Alex. Alex also has explanations and examples, and sometimes they even have their own videos posted on there. So make sure you're using Alex too. That's another big resource. All right. So looking at this one, we're going to go ahead and get started. So I tried to bring this down so there wasn't quite as much writing, but there's still going to be a little bit. So make sure what I'm going to have you do is I'm going to have you draw the diagram like this. It's actually this exact same diagram, so it doesn't matter which one you draw here. But on your notes, I want you to draw this diagram. So literally, if you just draw two lines crossing each other and then connect to make two triangles, you will have drawn the diagram. It's a very easy one to draw. Just kind of draw a very big X and then connect the ends there so that you have your triangles. Make sure you put the X, the 7.5, 4.5, and the 5 here. So if you need to, pause the video because I'm just going to keep kind of talking here, but you might need a few extra seconds to draw that. Make sure that we're going to label the vertices below. So vertices are all these points, right? We're going to label them so that we can actually look at corresponding sides. Remember, corresponding sides are the ones that relate to each other. So we have triangle ABC and triangle ADE. And you can see I have ABC, ADE. So I've just labeled them right next to it. And if you just put the letters kind of right next to the vertice, that's perfectly fine. You don't need to have these little lines. Oh, I don't know, I disappeared there. So now we're going to look at corresponding sides. So AC corresponds to AE. If we look at the diagram, here's AC, and it's going from the center point over to the right angle. So I have center to right angle. So if I do the same thing on the other triangle, I go from center to right angle, that's AE. So that's why they correspond. They're in the same position. I can describe them basically the same way. So sometimes we can say the left side, the right side, the bottom. But in this case, it's a little easier if we look at where they're intersecting. Where's, this point and the right angle. I think it's a little easier to describe it that way. So from the center point to the right angle, center point to the right angle. So the next one, and you can even see they're color coded, so I'm going to look at the blue ones. So I have AB and AD. So AB is the center point to this other angle, or this, farthest away angle, however you want to describe that. So that's AB. And then I have AD, same thing, it goes from the center to this other angle, this one that's kind of the farthest away. So these two are corresponding to each other. They're in the same position. I can describe them the same way. And then the last one are the green ones here. We have CB and ED. So C starts at the right angle and moves down to that other angle, B, so CB. So if I look at the other triangle and I go to the right angle, I have E, and that moves to the other angle, D. So we have these three corresponding sides. We need to be able to match them up so that we can write a proportion for these guys. So I just showed you this again, so it's just a smaller picture of what we just did there. So now we're going to write a little proportion. We don't need all of the sides. We want to focus on the sides that we actually have information on. So CB and ED, the two green ones, we have no information here at all, right? They didn't give us anything on the diagram. So we really don't care about those ones right now. There's nothing I can do about it because I don't have any information on it. So we're going to focus on the first two that we wrote, AC and AE, AB and AD. So if we write a proportion, AC goes with AE. So this is that center to the right angle, center to the right angle, and then AB and AD. So AB goes from center to the other angle, AD goes from center to the other angle. So here's my proportion. Well, I have some actual measurements for these, right? I know what AC is. AC is X. So I can fill that in. I know what AE is. AE is 4.5. AB, well, that's 5, right? And AD, that's 7.5. So I can fill in 3 of these lengths. The only one I don't have is AC, which is X. That is what they're asking us to find, right? So by labeling the vertices, that made it a little easier to reference some of these. Without the A, B, C, D, E, it's a little harder to reference the sides. So that's the reason I had you label it, was just so that it's easier to actually talk about, the length here. Instead of just saying this length and this length, I have AC because it's A is this dot and C is this dot, right? So I can label that AC, and I can label this one AE. So it just makes it a little easier to refer to. So now once we have a proportion set up, which is a fraction equaling a fraction, we use cross multiplication to solve this. You don't necessarily need to write these sentences out like this. That's not what I'm asking you for your notes, but make sure you have your diagram, and we definitely look at the proportion. So I would expect to see the diagram. I'm hoping to see this piece here, but definitely I should see this proportion, and then of course the filled in proportion and the math that we're going to do with it here. The proportions, just writing these two things without the diagram doesn't really mean anything. That's not going to be helpful in your notes at all. These notes are for you to use on your homework later. So the more you write down, the better these will help you. So make sure that you're drawing the diagram, labeling the vertices, and giving yourself enough to understand, what did I do? How did I get from here to here to here using these pieces? All right, so let's go ahead and look at cross multiplication. So we have x and 7.5 because we're going across from top to bottom. So that's x times 7.5, and that's going to equal the other cross multiplication. So 4.5 times 5, like that. So what this does is it gets rid of the fractions. That's why we cross multiply. Okay, so we no longer have fractions. The first cross multiplication equals the second cross multiplication. And it's actually, we're getting rid of the pieces. We're multiplying by 4.5 on both sides. We're multiplying by 7.5 on both sides. But we're doing it in a little bit of an easier way. Instead of showing each one of those, we're just cross multiplying. So if we reduce those, we have 7.5x, because these guys just get smushed together. And then 4.5 times 5 is 22.5. And the last step that we want to do, we want to get x by itself. So I'm multiplying by 7.5. The opposite of multiplication is division. Oh, I think it's down here. It got cut off a little bit. Usually I have my divide by 7.5 on both sides, so you can see it. So we'd be dividing by 7.5. Well, 7.5 divided by 7.5 is 1. That cancels out. That's why x is by itself. And 22.5 divided by 7.5 is 3. Darn it, why did I move forward? Is 3. So the value of x, which is AC when we gave it labels, is 3 in order to make this proportion correct. All right, so we're going to keep moving to the next guy here. So I don't know why this thing keeps bouncing around. It's being a little crazy. All right, so now we have indirect measurement. So this is a way that we can measure something that we couldn't directly measure. That's why we call it indirect measurement. So it wouldn't make sense to take out a ruler or even a tape measure to measure certain things, like say the height of a house, which is what we're going to look at here, a height of a building. Well, if we know certain measurements of other pieces, then we can apply that to find the measurement of, say, a height of a building. So the first thing I like to do, number one, we're going to read the problem, and then we're going to draw a picture so that we can picture this. So a pole that is 3.1 meters tall casts a shadow that is 1.77 meters long. So I know how tall the pole is. I know how long of a shadow it has. At the same time, a nearby building casts a shadow that is 40.5 meters long. How tall is the building? So I don't know how tall the building is, but I know how long of a shadow it casts. And we're going to round our answer to the nearest meter. So don't do any rounding until you get to the very end. So now we're going to draw a picture. When you're doing this problem, you don't necessarily need to write down this sentence. We're going to put all this information in the drawing. You can write all of this down if you want to, because again, the more you write down, the more it will make sense when you look at it later. Okay. So here's the pole, and it's 3.1 meters tall, and it's got a shadow of 1.77 meters. Here's my nearby building. I don't know how tall it is, so I said h meters tall for the height, right? And then it has a shadow of 40.5 meters. This looks a little bit more like a road. It was meant to be a shadow, I swear. So now what we want to look at is how do we kind of relate these two things together? Because in the last one, we were looking at two triangles. Well, if we think about the sun, because we have these pieces here, right? They're both perpendicular to the ground. So I have this right angle here because hopefully they're going straight up and down from the ground. We don't want this guy to be crooked, or the house probably isn't going to be crooked. It's going to be a perpendicular line right through the middle. We also have the sun that's shining down at the same angle because at the same time. So it's going to be creating this angle that's the exact same here, or I could even look at the top here. It would create the same angle at the top. So this is one of those properties that we can throw out there. It's called angle-angle similarity, which means if I have two angles of one triangle congruent to two angles of another triangle, the triangles have to be similar. Not congruent, but similar. We've been dealing with a lot of similar things here in 8th grade lately. So It just means that they're proportional, just like the last ones we looked at, right? So we have corresponding sides that will be proportional to each other, or they will relate to each other. Oh, darn thing. Okay, so I scooted this guy up. You can't see the sun anymore, but you can still see the measurements. I don't know why that switched to Y instead of H. Interesting. So we're going to match up the corresponding lengths, okay? So the height of the building would correspond to the height of the pole. Height and height. So the height of the building, and I know I had it H before, but now it's Y. So I have Y, and the height of the pole was 3.1. They told us that. So Y corresponds or relates to 3.1. Then I have the shadow of the building, and that corresponds to the shadow of the pole. So the shadow of the building was 40.5. The shadow of the pole was 1.77. So I have quite a few relations here. The only thing I don't know here is Y, which is the height of the building. So the lengths of the corresponding sides are proportional, meaning they're related to each other. So we can actually start to write that out. So I have the height of the building and the length of the building shadow. So the building are the numbers that are on the top of my proportion. On the bottom of my proportion is going to be the pole. So you have to make sure that you're separating that out. So you can think of it as height to height, shadow to shadow, or building to pole. Okay? So it kind of just depends on how you separate that out in your mind. But the height of the pole is 3.1, and the shadow of the pole is 1.77. So here I have my proportion set up, just like I did on that last one. So now I'm going to cross multiply, just like we did on the last one. So I'm going to go Y times 1.77, and then I'm going to go 3.1 times 40.5. Now, just like we did in the last one, I want to combine these two pieces. So when I multiply these, they just get squished together, right? Because I can't really do these yet. But I can multiply 3.1 and 40.5. I get 125.55. Don't do any rounding yet. We don't want to round. We're not rounding until we get to the very, very end. Okay? Because if you round inside of the calculations as intermediate computations, just kind of, that means, within the problem, you might end up with a different answer because you've rounded too many times. So just don't do that till you get to the end. So now we're going to take the 1.77, it's being multiplied by Y, we're going to divide it away. So I'm going to divide both sides by 1.77. Well, 1.77 divided by 1.77 cancels, so I just have 1, because it cancels to 1, so I just have Y. 125.55 divided by 1.77 is 70.9. Now we need to deal with rounding, because if you were to type this into Alex, it would say you were wrong, because part of the instructions were to round. So we need to make sure that we round it up. 9 is 5 or bigger, so that's going to round the 0 up to 1 instead of back down to just 0. So basically we're saying, what is it in between? Is it closer to 70 or 71? Well, 9 is definitely closer to the next number, so we go up to 71. Okay. All right, let's go ahead and keep moving here. So we're looking at day 2 now. This is the second problem. I'm not going through each and every single problem. Some of these are a little difficult to do in this type of setting because it requires some of the Alex tools to do them. So you may have to kind of look at the examples and see on some of them how to do this. So I'm going through all of the problems that are possible in this type of setting. So finding angle measures of a triangle given two angles of a similar triangle. So the first thing we need to remember is this triangle angle sum theorem, which we've learned, I want to say we've learned it a couple of times this year already, but I wanted to remind you. So the sum of the interior measures of an angle of a triangle is 180 degrees. So I want you to write that sentence out. The three interior angles of a triangle add up to 180 degrees. We need to remember this. We will use this multiple times within this class. You will continue to use it when you get to high school. So make sure you want to remember this statement. And what this helps us do is if we look at the diagram here, we have triangle PQR, and I know angle R and I know angle P, but I don't know angle Q. But if I know this property, that all three angles have to add up to 180 degrees, that's going to help me find angle Q. So now I can go over here and say, well, 15, which is angle R, and 35, which is angle P, plus whatever angle Q is, have to add up to 180 degrees. They have no choice. That's the rules here for the triangle. So I'm going to combine these two. So 15 plus 30 is 50, plus angle Q is 180. So the only thing that's changed is I combine these two numbers. So now if I know they have to be 180 and I'm already using 50, I'm going to subtract 50 from both sides. I want to know what is left over for angle Q. So angle Q has to be 130 degrees. So now I have the three angles filled in. I know these three. They told me that the triangles are similar, which means that the angles are congruent. And we've done different not experiments, but examples in class to show you that. I don't know if you guys remember when I held up the triangles in class that were the same, and then I projected one up on the board, which means I dilated it, I made it bigger, but the angles still matched up perfectly when I walked up to the board with the small triangle. So when we have similar triangles, the side lengths change. They're going to increase or decrease, but the angle measures are still congruent. They still match. Okay. So now I can go through here and say the angles of triangle PQR, I'm going to list them from smallest, largest, medium. I'm going to list them in order. And they will match the smallest, largest, and medium angles of ABC because they are similar triangles. So the smallest angle of PQR is 15. Right? I have 15, 35, and then we found this one was 130. So 15 is definitely the smallest. So angle R, which is 15, so I'm going to look at the smallest angle over here of ABC, which is A. That's definitely the skinniest little angle there, right? So if R is 15, A is also 15. The largest angle, well, if it's 15, 35, and 130, 130 is definitely the largest angle there. And then if I look over here, I can visually see that B is the largest angle, right? And if Q is 130, remember similar triangles, congruent angles when they're similar triangles. So if Q is 130, B is 130. And then the last one here, medium, it's just the other angle, is that P, which is 35 degrees, and it's the other one that's left over here, which is C. So if this one's 35, this one has to be 35. So we're just matching up, smallest to smallest, largest to largest, medium to medium. Okay. So this guy is a little bit harder to do without the worksheet. So do the best you can. You want to kind of see, so do the best you can drawing these guys. I know that's a little bit more than I usually ask you to do in class for sure. But you want the diagram to go with this. Otherwise, this isn't going to really mean anything. Okay, so make sure you pause the video for a moment and kind of, if you don't have grid paper, you can kind of easily draw a grid. Just draw two lines crossing each other and then give yourself some lines here. So do the best you can to kind of draw these guys. And then we're going to look over here and we're going to say find the run, rise, and slope given by triangle ABC. So we're looking at the bigger one, A, B, C. So the run, we want to know what's the run here. So because the slope is rise over run, we're actually relating these two things. So here, and I went with rise first for whatever reason, I'm rising 8 units. So from A to B, I'm going up 8. From A to C or C to A, I'm going over 4 to the right. So it's positive 4. So I'm filling my pieces in here. And now I'm going to put it in to my slope. Remember to reduce so that it's comparable. So 8 over 4 actually turns into 2 over 1 because 8 can divide by 4 2 times. 4 can divide by 4 1 time. Right? So it actually reduces down to 2 over 1. Now we're going to look at the same thing for triangle DEF. Oops. That animated funny. The 2 over 1 shouldn't be there yet because we have a rise of 2 and a run of 1 for this guy, and I know they're out here because I didn't have room to write them in there, but you can still see these guys, and I filled them in. Rise of 2, run of 1, so we can see that 2 over 1. So that matches, the slope matches on these ones. So down here, and you can see it bubbled itself in already, there are 2 slopes computed above equal? Are the two slopes above completely equal? Why or why not? Well, yes. So we know it's going to be a yes. So we're going to ignore the no's. So there's two yeses. Yes, they are equal because the two triangles are similar. Yes, they are equal because the two triangles are congruent. Well, we know the two triangles are congruent. They're different sizes. So these triangles would be similar. That's why we would find the same slope. And we actually call these slope triangles. We can prove the triangles are similar based on their slopes. So this is actually from day 6. We're working ahead a little bit. And I haven't explained this to everybody. There's actually going to be a week that I'm out. So I'm trying to kind of bridge that gap a little bit with this week. So using a scale drawing to find actual area. A scale drawing for a restaurant is shown below. In the drawing, 2 centimeters represents 3 meters. So over here, I'm actually going to put that over here. 2 centimeters represents 3 meters. That is our ratio, our scale factor. Every 2 centimeters is actually 3 meters in real life. So assuming the dining hall is rectangular, find the area of the real dining hall. So they're giving us kitchen and dining hall. We don't care about the kitchen. They're giving you too much information. Okay? They want to see if you know to focus on the dining hall. That's what they're kind of testing you on here. So make sure you're paying attention to what they're asking you to focus on. And remember, area, if we're looking at just rectangles, is length times width. So in order to know the area of the real dining hall, I need to know the length and the width of the real dining hall. I know the length and the width of the scale model, right, or the scale drawing. It's 8 centimeters by 4 centimeters. So we're going to look at our proportions. Remember, they're proportional. That's what a scale is. It's proportional. Sorry, I didn't quite cut off some of the writing there like it was supposed to. So I have 2 centimeters over 3 meters. I'm going to use that scale. And then I'm going to focus on length first. And I decided that 8 was the length. It doesn't matter which one you label length and which one you label width. You just kind of have to stick with it once you've labeled it. Oh, this thing is just jumping ahead. Interesting. Okay, so 2 centimeters times L, because I have a proportion set up. So I'm going to cross multiply. And then 8 times 3. So with this guy, I'm just going to reduce. 2 times L is 2L. 3 times 8 is 24. I'm going to divide by 2 on both sides because I want to get L by itself. So I end up with L is 12 meters. So the real dining hall is 12 meters long. I need the width also, because remember, we need length and width to calculate area. So I'm going to start with my 2 over 3 again. That's my scale factor. And now I'm going to look at the width of the drawing, which is 4. I don't know the width of the real dining hall. That's what they're asking me to find, part of it. Now I'm going to do my cross multiplication again. 2 times W and 3 times 4. So now I just need to reduce again. So 2 times W is 2W. 3 times 4 is 12. And again, I'm going to divide by 2 on both sides. 2 divided by 2 cancels. Oop, and that should say W, not L. Because 12 divided by 2 is 6. So this should be the width is 6, not the length and the length. That was silly of me. Little typos here that I'm finding. All right, so now I have the length and the width. So what I'm going to do, and you can see I did it again and it still says L there. That should say W, darn it. So area of a rectangle equals length times width. So I want to go through, and darn it, didn't animate. All these little tiny mistakes I'm finding. So the area of a rectangle is 12 times 6, because 12 and 6 for length and width. So when I do 12 times 6, I get 72. Make sure, because it may make you put, darn it, I don't know why it's going backwards. That's weird. It's going to have you choose your unit. So it's not meters anymore. Now we're looking at how much space it takes up, not how long it is. So I need to do 2 dimensions, meters squared. Okay. So make sure you're going through, why does this thing keep going backwards? Just make sure, go through, take your notes on this guy. And then you can submit your notes on Google Classroom so that I can give you attendance for the day if you were not able to attend the Google Meets math class. So I hope this helps. Let me know if you have any questions on it. I know it's kind of a quick version. It's only 30 minutes long here, but you can definitely pause it as you need to. And I wanted to make sure that you had everything you needed to do on your homework, because we don't have time to push things out like we did last semester. This last part will be available to you actually next week because we're working a little bit ahead on it. So I may change that on Alex to scooch it forward so it's already available to you. All right. Well, that's all I've got for you today, and I will see you in person next week.